morning, HOD Professor P. Chaturvedi sir, my seminar guide S. Meena sir, seminar coordinator D.P. Sharma sir, faculty member, examiner and my friend. I am Priyanshu Gupta, pursuing my B.Tech from University Department of Mechanical Engineering, Rajasthan Technical University, Kota. My seminar topic is a review on ultrasonic welding. This is going to be our list of content. Firstly, we will discuss about introduction of ultrasonic welding. Ultrasonic welding is a process that uses high frequency vibration to join two metals together. This method is commonly used in manufacturing industries for joining plastic, metals and other materials. Now we will discuss why we use ultrasonic welding. Ultrasonic welding is fast, efficient, non-contaminating and require non-consumable. In ultrasonic welding, no external heat used, only frictional heat produced by the ultrasonic waves are used for the joining process. Then principle of ultrasonic welding. In ultrasonic welding, frictional heat produced by the ultrasonic waves and force is used for the joining process. Ultrasonic waves are transferred to the material under pressure with a sonometer. The welding can proceed with or without application of external heat. System component and function. Basic ultrasonic assembly consists mainly of four major components. Generator. Generator changes standard electrical power into electrical energy at the frequency at which the system is designed to operate. Transducer. Transducer changes the electrical energy into low amplitude mechanical motion or vibration. Booster. Booster is used to increase or decrease the amplitude of the vibration. Horn. The design of the horn is determined by the amplitude, the type of welding process and the material selected. Ultrasonic welding mechanism. The basic process of ultrasonic welding can be described by the following steps. First, the parts to be welded are placed in the anvil or fixture. The horn contacts the part to be welded. Third, pressure is applied to keep the horn in contact with the welded material and hold them together. The horn delivers ultrasonic vibration to heat up the material. The vibration moves less than a millimeter either up and down or side to side. If the horn gets detected and the welding material can be removed from the anvil. In metal, the ultrasonic vibrations are delivered parallel to the plane of the material. The frictional heat increases the temperature of the metal surface to about 1/3 of its melting temperature. In case of plastic, the vibrations are perpendicular to the plane of the material and frictional heat increases the temperature enough to melt this plastic. Advantage of ultrasonic welding. First, heat affected zone is minimized. Second, very thin metals can be welded. Third, welding of glass is possible. Fourth, dissimilar materials can be joined. Fifth, surface deformation is minimum. Sixth, equipment is simple, moderate scale is enough. Disadvantage of ultrasonic welding. Process is limited to lap joint, restricted to joint metals. Third, a high initial investment. Fourth, is suitable for hard, moisture containing plastic. Fifth, material being welded may tend to weld to the tip and anvil. Welding. In computers and electronic industries, ultrasonic welding used in computer-based semiconductor devices. In aerospace and automobile industries, ultrasonic welding used in door panels, lamp, air duct, steering wheel, and engine components. In medical industries, ultrasonic welding used in face masks, blood and gas filters. In packaging industries, ultrasonic welding used in food, fireworks, and chemicals. And conclusion of ultrasonic welding. Ultrasonic welding is environment friendly since no flux material is required in order to join metals. Joints produced by ultrasonic welding are stable, strong, and the composition of this single material is not damaged, so the chemical structure stays constant throughout. Moreover, energy consumption is low, thus energy is saved. So that was all about my seminar topic. Thank you.